I'm skipping from having just done 1.5 to doing 1.8 because I know that's the one that you're going to need right now, should you choose to watch it. And then 6 and 7 I will put up in time for you to use for your review. So 1.8 is about absolute value. So when I write this means distance from 0. So on a number line, it means other things elsewhere, but since we're doing functions on real numbers, it means distance from 0. So 2 is 2 away from 0. If I put in -3, its distance from 0 is 3. So at any rate, it really means length, kind of, but from the origin. So at any rate, you just get a positive. So because this is just on the real lines, the only thing this function does is switch the sign, if it's negative and not if it's positive. However, you might see something like then what people tend to do is subtract the 1 and write the absolute of x minus 4 is 0, x is 4 minus 4. This is, you've got to be careful. So at first treat this like the object for which you're solving. And so as of now, it's already solved for. Like there's not move stuff around to do it this time. And then you say, okay, whatever's under here, whatever's inside there, is either 1 or -1, because those are the two things that are 1 unit away from 0. If you look on a number line and you go 1 unit in either direction, you get 1 and -1. That was weird. Okay, so either this is 1 or it's -1. Now I can start solving for x because I don't have those grouping symbols anymore. So add 3. And these are my two solutions. You could also have, instead of equal to, greater than or equal to, less than or equal to. So let's look first at less than or equal to. If my distance from 0 is less than or equal to 3, then I am closer to 0 than 3, or the same distance, right? The equal sign means it's okay to be equal. So I'm going to go over to 3 and say it's okay to be this far, and also any place that's closer to 0 than that. But I could have gone the other direction. This is also 3 away, so any of that. So you can write x is less than or equal to 3 and x is greater than or equal to -3 because it's trapped in here. Or you can just write it like this. This only works when you're trapping. Okay, so when you're creating this single interval. So what if instead x was in absolute value greater than 4? So first of all, the greater than means I can't be 4 away. So I have to be farther away than 4. So here are the two things that are exactly that distance from 0. So those are open circles, meaning I'm not including 4 and I'm not including -4. But I've got to be farther away, so over here, or over here. So I no longer have an and. Things which are bigger than 4 are not less than -4. So I can't put an and that wouldn't leave any numbers. It's an or. It's either you're over here or you're over here because it's two different locations. So x is bigger than 4 or x is less than -4. And we don't have any kind of handy symbols to write that. You have to do both pieces and say or. So what if I have then because it's a less than, I have an and. I can write it all in one thing, or I can write it with an and. I prefer to write it all in one thing. So whatever's under there is already isolated. So I can just go ahead and do that part. And then once I have this, I add 5 to both sides. Divide by 3. If this was negative, I would change the signs everywhere. So negative 1/3 less than x less than 11/3. The reason that I would change if it was like negative x, say is less than negative 5, and then I want to divide out the negative 1. The deal is that every time I do a negative, I cause a reflection. So if I do a negative on x, I'm reflecting over 0. So here's 0, 2, negative 2, they're reflections of each other, right? So if I have negative x, then when I change its sign, I've reflected it. So if I go down to, let me see a little lower so I can get a negative 5. If it's less than negative 5, that means it's here. So when I change it from negative x to positive x, I have to reflect it over. So it's a reflection. And now it's a smiley face with an arrow through his head. But anyway, now, so reflecting it over, this sign changes too, but so does that one, because now it's bigger. Okay. So, I'm trying to think of a good modeling problem where you would have absolute value. Let's say that your profit from something was let's say your cost for something was going to be, say, $2 per item plus some initial startup cost, say $10. And let's say that you wanted to keep your cost close to $50. So you wanted to say, okay, I'm going to take my cost and I want to be no more than $5 away from $50. So I want to spend about $50, give or take 5. So the difference between your cost and $50, which is what's in here, should be an absolute value less than or equal to 5. I said give or take 5, so it could go either direction, negative or positive. So first you rearrange the stuff in here. And then because it's a less than, it's a trapped. And then you divide by 2. So what this means is, I'm assuming that whatever the item is, I can't make half of it. So this means that I actually need to do 18, 19, 20, 21, or 22. Because if I do 23, I'm outside the range. If I do 17, I'm outside the range. The only other thing that really might happen that I can't think of a good modeling situation to set up is you might have, say, and you have to isolate this first. So you first treat this like x. Let me make this greater, just so we have an order. Then you do the next part. So either this is bigger than or equal to 8, so I'm just copying it down, or, so you copy it down again and change both signs, so the sign of the number and the sign in between is the opposite, and then you write or if this was greater, and you write and if this was less, because it's trapped. Okay, I think that should be it for 1.8. Let me know if it's not.